By July 2026, technology is accelerating at an incredible pace. We have artificial intelligence that seamlessly listens and interrupts you in real time. We have reusable rockets flying their 36th consecutive mission, and aerospace engineers are successfully testing engine designs capable of passenger flights at Mach 5. But beneath these massive milestones is a much quieter reality. Digital game libraries are disappearing. Acclaim studios are deaded to make room for predictable corporate bets, and AI coding assistants are secretly installing malware directly into the software supply chain. Both realities are the result of a single, obsessive philosophy driving the modern tech industry: hyper-optimization. The goal is to aggressively engineer every ounce of friction from our physical and digital systems. Stripping away that resistance is what creates our modern miracles. But when you systematically eliminate all friction from a system, you also remove the baseline limits that protect the people using it. Look at the aerospace industry to see the raw power of physical optimization. Earlier this month, SpaceX launched a specific Falcon 9 booster, serial number B1058, for a historic 36th time. This chart shows the economic impact of reusability. Building a new Falcon 9 costs roughly $60 million. By reusing a booster, SpaceX cuts the per-mission cost to $28 million. That's a massive 50% expense reduction for a single flight. Now, a Texas startup called Venus Aerospace is attempting the next radical step in physical optimization with their rotating detonation rocket engine, or RDRE. Traditional jet engines rely on continuous fuel combustion. The RDRE deletes that process entirely. Instead, it uses a controlled detonation wave that rotates at several thousand meters per second inside the chamber. This precise explosion generates thrust while saving 25% on fuel, bringing commercial Mach 5 travel into the realm of viable engineering. We are seeing this same drive for zero latency efficiency in software. OpenAI recently restructured the entire architecture of how humans converse with their models. Previously, AI voice chats worked in clunky turns. You spoke, you waited, it processed, it responded. The new GPT Live model uses a full duplex system. It runs parallel processing streams for transcription, response generation, and voice synthesis all at the exact same time. The result is a response latency of under half a second, meaning you can casually interrupt the AI mid-sentence. Whether it is a manufacturing cycle, a combustion chamber, or a conversational pause, deleting the middle limits of a system results in pure, miraculous efficiency. The problem is, what happens when major corporations apply this exact logic to their business models? Both Sony and Microsoft are rapidly pushing the consumer market toward digital-only, diskless consoles. This pie chart shows a $70 physical game sale. Retailers take $21. Distribution costs $3.50. Sony keeps $45.50. Watch the digital ecosystem. By eliminating middlemen, the console manufacturer captures the entire $70. That is $24.50 in additional, frictionless profit generated on every copy. The hidden cost here falls entirely on the consumer. True ownership is optimized away. You are left with a digital license that can be revoked at any time by a server shutdown or an account ban. Microsoft is applying this exact same ruthless efficiency to creative risk. In a major restructuring, they recently canceled Obsidian Entertainment's highly anticipated original game, Avowed 2. The math behind the cancellation is highly practical. The Amazon Prime Fallout television series recently pulled in over 65 million viewers. Rather than risk capital on an unproven creative property, Microsoft gutted Obsidian's team and reallocated to resources to rush a highly profitable Fallout sequel. In a hyper-optimized corporate structure, consumer rights and creative risk are treated as inefficient friction, so they are deleted. This blind pursuit of efficiency gets significantly more dangerous when it intersects with global cybersecurity. Researchers at MIT recently discovered a new exploit in the AI coding ecosystem called halluci-squatting. When an AI coding assistant doesn't know the exact name of a software library, it will often hallucinate a fake one. Hackers are now using statistical analysis to predict exactly which fake package names the AI will inevitably invent. This flowchart maps the attack. First, AI hallucinates a fake name. Second, hackers register malware under that exact name. Third, the AI recommends it, and the developer installs it. 9 major tools are affected, hitting a 23% success rate. Millions of developers blindly trust AI to speed up their workflow. But when human developers optimize away their own manual code review, they create a frictionless, high-speed highway for malicious infiltration. The technology industry is obsessed with building a closed loop of absolute maximum efficiency. They want systems that operate without a single point of drag. We cannot ignore the tangible benefits of this loop. It gives us highly affordable access to orbit and flawlessly natural artificial intelligence. But the exact same logic allows corporations to monopolize digital ownership and empowers bad actors to distribute supply chain malware at scale. For decades, we have operated under the assumption that all friction is an engineering flaw that needs to be solved. In a hyper-optimized world, friction is no longer a bug in the system. Physical media on your shelf, hours of manual code review, the risk of new ideas, these are the only remaining safeguards we have left.